So if the nucleus is positively charged, then our nucleophile must be negatively charged, right? That is how they are having an attraction with each other. So from this pi bond, the electrons are moving to the next adjacent bond. So what happens? Earlier, the double bond was here. The pi electrons moved to the adjacent position and now the double bond is here. If an atom attached to the carbon chain is more electronegative than carbon, then the carbon chain acquires a partial positive charge and this is known as minus I effect. Hello everyone, this is Ambali Unikrishnan from the Department of Chemistry, Vidhyaashram Pre-University College, the Temple of Excellence, Mysore. So today we are back with session 6 of the chapter Organic Chemistry. So in the last session we studied isomerism, different types of isomerism, as well as we started with the fundamental concepts in organic reaction mechanisms. Right. So in today's session we are going to study about what are nucleophiles. Right, these are important in reaction mechanisms, right? So what are nucleophiles, electrophiles? And then we'll be studying about electron movement in organic reactions. We know that electrons are the ones which take part in chemical reactions, right? So the movement of the electrons is also important in the organic reaction mechanism, right? So the electron movement, how it will be, we will be studying. And then electron displacement effects in covalent bonds. There are various electron displacement effects that you have to study in this chapter. We'll begin with the first one in this session, that is inductive effect. So beginning with the first topic for today, that is nucleophiles. So what are nucleophiles? From the word you can see nucleo and philes. So phile means loving. The word phobia means you are having fear of something, right? And the phile or philia means love for something, right? So nucleophiles, that means they are nucleus loving species. Okay, so if someone is having an attraction towards nucleus, we know that nucleus is positively charged, right? So if someone is having an attraction toward nucleus means that particle must be negatively charged, right? We know that negative and positive charge will have attraction. So if the nucleus is positively charged, then our nucleophile must be negatively charged, right? That is how they are having an attraction with each other, right? So any species which can donate one or more electrons is a nucleophile. So nucleophile, as I said, they are negatively charged species. That means they will be having one or more electrons which can be donated, right? And nucleophiles are electron rich species. They are electron rich species. They are either negative ions or neutral molecules with at least one lone pair of electrons. So they will have at least one lone pair of electron which they can donate, right? So nucleophile means they are negatively charged particles or neutral particles having lone pair of electrons. So let's see a few examples here. The examples that are given here are negatively charged nucleophiles. Cl minus, Br minus, I minus, NO2 minus, NH2 minus and R minus. All these are examples of negatively charged nucleophiles. Now these are neutral nucleophiles having lone pair of electrons, right? So NH3, ammonia, it has a lone pair of electron. Nitrogen has a lone pair of electron. Water, the oxygen is having two lone pairs of electron. And what is this? This is alcohol, ROH, general representation of alcohol, right? So in the oxygen, it is having two lone pairs, right? So these are nucleophiles. And all nucleophiles are Lewis bases. All nucleophiles are Lewis bases and nucleophiles is generally represented by the symbol Nu and two lone pair and the pair of and the lone pairs is represented here with a negative sign. How do you represent it? Nu stands for the nucleophile and the lone pair and a negative charge. So this is how you represent the nucleophile. Either it will be negatively charged or neutral charged species having more than one electron to donate. That is, a lone pair will be present, right? So these are nucleophiles. Now moving on to the next one, that is electrophiles. So now nucleophiles were species which are having attraction towards nucleus. Now what is electrophiles? Same way, which is having attraction towards electrons. So electrons is what charged species, negative or positive. Electrons are negatively charged species, right? So if electrons are negatively charged species, electrophiles must be positively charged, right? So any species which can accept one or more electrons is an electrophile. And electrophiles are electron deficient species, and they are either positive ions or molecules with incomplete octet. So in the case of nucleophiles, they can donate electrons. In case of electrophiles, they accept electron. Right? They can accept one or more electron, and also they are electron deficient species. They lack electrons, so what do? They try to accept more electrons. So they are either positively charged species or having incomplete octet. So these are few examples of positively charged electrophiles: H+, H3O+, NO2+, R+, and NH4+. All these comes under positively charged electrophiles. And BF3, AlCl3, SO3, FeCl3, these are neutral electrophiles. BF3, we know that it is having incomplete octet, right? So all these are examples of electrophiles, right? And all electrophiles will be, yes, Lewis acids. All nucleophiles are Lewis bases. All electrophiles are Lewis acids, and electrophiles is generally represented by the symbol E and then a plus sign. Right? So this is nucleophiles and electrophiles. Now moving on to the next concept, that is electron movement in organic reactions. So the direction or the movement of the electrons in an organic reaction has to be specified. So how do we show that in which direction or from which atom to which atom the electron is moving? Yes, is there a bond formed? Regarding all of that, it comes under the electronic movement in organic reaction, and how we are going to represent it. Right. So the movement of electrons in organic reactions is shown by curved arrow notation. It is shown by using a curved arrow. Curved arrow starts from where an electron pair is shifted, and it ends at the location to which the pair of electron may move. Okay. So the arrow starts from the atom which is donating the electron, and yes, it ends, that is the head will be towards the atom to which the electrons is being donated. So let's see the first one. From a pi bond to adjacent bond position, the electron is moving. So from a pi bond means, yes, double bond or triple bond. Pi bond means in a double bond there will be a sigma bond as well as a pi bond, right? So from this pi bond, the electrons are moving to the next adjacent bond. So what happens? Earlier the double bond was here, the pi electrons moved to the adjacent position, and now the double bond is here. Okay, so how do I represent it? From here the arrow starts and it should be end, that is the head of the arrow should end in this bond. Alright, so this is how we represent it. Next one is from pi bond to adjacent atom. Okay, from pi bond to the adjacent atom, the pi electrons, that is the 2 electrons, is going to the adjacent atom. So the atom here is Y. As you can see, it is shifted to this position, and what happens on Y, you can see these 2 electrons, that is a lone pair. Right. The next one is from atom to adjacent bond position. So from the atom is having a lone pair. From the atom, it is going to the adjacent bond position. So now a pair of electrons is going to this position, means now it will form one more bond. This becomes a double bond then, right? So these are few examples that you can see of the electron movement, right? Now the movement of single electron is indicated by half-headed curved arrow known as fishhook arrow. So there is in a bond there are 2 electrons. If the bond is breaking and each of the atom is taking up 1 electron, that is the movement of single electron, it will be shown by a half-headed curved arrow which is known as fishhook arrow. So as you can see in this example, CH3Cl. Yes, there is a bond that you can see. Now 1 electron goes to the alkyl CH3 and 1 goes to the chlorine. So what happens? As you can see, it is shown by half-headed single arrows, right? So this is called as fishhook, and this what you have got here, it is called as the radicals, right? Odd electron species are called as radicals, right? So that will be, that is this movement of single electrons will be shown like this, right? Now moving on to the electron displacement effects in covalent bonds, right? So the displacement of electrons in covalent bond takes place either by the influence of atoms or group of atoms present in the molecule, or by the influence of attacking reagent. As a result, carbon chain gets polarized, right? So in the carbon chain, there can be effect because of the presence of atoms or groups. Yes, in the molecule there will be various atoms and molecules, right? And also by the influence of attacking reagent. Okay, so as a result, what happens? There will be a polarity difference, right? In a molecule, there will be different atoms, right? If there is a electronegativity difference, there can be a polarity which will be developed. So based on this, there are various electron displacement effects that we have to study. There are 4 effects that you will be studying in this chapter: inductive effect, electromeric effect, mesomeric or resonance effect, and the last one is hyperconjugation effect. So in this session, we will begin with the first one, that is inductive effect. Okay, so what is inductive effect? The permanent polarity produced in a carbon chain due to the partial displacement of a bond pair of electron towards the more electronegative atom or group. So it is a permanent effect, okay? It is a permanent polarity produced in a carbon chain when there is electronegativity difference between the 2 atoms. So as you can see in this example, CH3, CH2, Cl, right? CH3, CH2 and Cl. So between the carbon and the chlorine atom, there is an electronegativity difference. Yes, carbon or chlorine is more electronegative. Chlorine is more electronegative, right? So what happens is this shared pair of electron will be moving towards the more electronegative one. So hence what happens? There will be a polarity difference and chlorine will attain a partial negative charge and carbon will attain a partial positive charge. Now this is called as inductive effect. And there are 2 types of inductive effect as well, that is minus I effect and plus I effect. So let's see the minus I effect. If an atom attached to the carbon chain is more electronegative than carbon, then the carbon chain acquires a partial positive charge and this is known as minus I effect. So let's take this example, CH3Cl. Yes, so there is an electronegativity difference between carbon and chlorine. So the other atom which is present, that is chlorine, is more electronegative than carbon. So chlorine will attain a partial negative charge and carbon will attain a partial positive charge, right? So this effect is known as minus I effect. That is, the carbon gets the partial positive charge. Yes, it acquires a partial positive charge and the other atom which is present other than the carbon, that will attain a partial negative charge because it is more electronegative. That is called as minus I effect. And atoms or group which causes minus I effect are termed as electron withdrawing groups, or EWG you can write it, electron withdrawing groups, right? So they take up the electrons. So they are electron withdrawing groups. Now let's move on to the next one, that is plus I effect. If an atom or group attached to the carbon chain is less electronegative than carbon, then the carbon chain acquires partial negative charge. This is known as plus I effect. So as you can see, if there is a carbon and then there is another atom which is present which is less electronegative than carbon, then in such cases the carbon will attain a partial negative charge and the other atom which is present will attain a partial positive charge. So let's take carbon and hydrogen itself, right? Hydrogen is less electronegative than carbon. So in such cases the carbon will attain a partial negative charge and hydrogen will obtain a partial positive charge, right? So if the other atom which is present, if it is more electronegative than carbon, yes, the carbon will attain a partial positive charge which is called as minus I effect. And if the carbon is attaining a negative, partial negative charge, it is called as plus I effect, right? And atoms or groups which causes plus I effect are termed as electron releasing or electron repelling group. Okay, they release electron, they have extra electrons, they will release the electrons. Yes, hence they are electron repelling group. Alkyl groups like methyl, ethyl, etc. are considered as electron donating groups or electron releasing group, right? EDG or ERG, that is electron releasing group or electron donating group. Yes, and minus I effect showing compounds are electron withdrawing groups, right? Now moving on to some important features of inductive effect. It is a permanent effect. As said in the beginning, inductive effect is a permanent effect. Yes, a permanent polarity difference will be there and operates in saturated and unsaturated system, right? And then partial charges are also produced. Yes, one atom will acquire a partial positive charge which is less electronegative, and the other will be attaining a partial negative charge which is more electronegative. Now influence up to third carbon in the chain, right? So for that, as you can see in here, in this, yes, there is a polarity difference here, CH3, CH2 and Cl. So chlorine will attain a partial negative charge because it is more electronegative. Carbon will attain a partial positive charge, and the adjacent carbon atom will also attain a partial positive charge. But the strength of this will be less. That is, the inductive effect appearing to this carbon atom will be more than this one. So as we move away from the bond, the inductive effect also decreases, and it will last only up to the third carbon atom. So as you can see here also, it will only last up to the third carbon atom, and further carbon atoms will not have this inductive effect acting on it. Right. And the next one is strength of the effect decrease with increase in distance from the group attached to the carbon chain. So if your carbon chain is very long, immediate carbon atoms will be only having this inductive effect and the other carbon atoms will not be having. For example, if I am taking this particular compound, right, there is an electronegativity difference here. So chlorine will attain the partial negative charge, carbon will have the partial positive charge. Yes, and this will have also a small inductive effect happening, right? That is, it will attain a small partial positive charge, and it can happen to the third carbon as well. But the next carbons will not be having a much mentionable effect on inductive effect. So these are the few important features of inductive effect. So in the next session, we will be further discussing about the next 3 electron displacement effects, that is electromeric effect, mesomeric or resonance effect, and the last one is hyperconjugation effect. So I hope what and all we have discussed in this session is clear for you. So that's all for today. Thank you.